Imagine walking through a busy local taxi park in Uganda. If you are standing at one corner and your taxi is at the exact opposite end, you could walk all the way down the length, make a sharp 90-degree turn, and walk across the width. But to save time, you probably just walk straight across the middle, cutting diagonally through the park. That diagonal path is shorter than walking the perimeter. While it feels like common sense, it is the first clue that a consistent relationship exists between the different sides of a flat shape. This is Pythagoras' theorem. It states that for any right-angled triangle, the square of the two shorter sides added together equals the square of the longest side. We write this as a squared plus b squared equals c squared. That longest side, c, is called the hypotenuse. You can always identify it by looking for the 90-degree corner. It acts like an arrow pointing straight across at the hypotenuse. Local masons use this rule to make sure their house foundations have perfectly square corners. They take a rope tied with 12 evenly spaced knots and stretch it into a triangle with sides of 3, 4, and 5 units. Let's test the math on that foundation. We plug our shorter sides into the formula. The order of operations is critical. You must square the numbers before you add them together. 3 squared is 9, 4 squared is 16, and adding those gives us 25. Since 25 is c squared, we find the actual length of the third side by taking the square root. The square root of 25 is exactly 5. As long as your shape has a perfect 90-degree corner, knowing the length of any two shorter sides allows you to calculate the length of the longest side. This diagram shows a different challenge. What happens when we already know the longest side is 13 centimeters, but we need to calculate the missing height? We use the short side subtraction rule. If the hypotenuse is already known, you take its square and subtract the square of the other known side. We square 13 to get 169, square 5 to get 25, and subtract to get 144. Before moving forward, look at the triangle. Does a vertical height of 144 centimeters make sense attached to a 13 centimeter hypotenuse? It doesn't, because we haven't found the square root yet. The square root of 144 gives us the true height, 12 centimeters. Recognizing whether you are hunting for the longest side or a shorter side dictates whether you add or subtract your squares. Let's apply this to a practical task. We need to calculate the front area of this canvas tent. The shape is an isosceles triangle with a 6-meter base and 2 equal 5-meter slanted sides. To find the area of any triangle, we multiply the base by the perpendicular height. This means we cannot use the 5-meter slanted edge as our height measurement. To find that height, we drop a vertical line from the peak to the base. This splits the isosceles shape into 2 identical right-angled triangles with bases of exactly 3 meters. Now it's your turn. Use the short side subtraction rule to find the height of that center red pole. Pause the video, calculate the height using the 3-meter base and 5-meter hypotenuse, and press play when you have your answer. Symmetrical shapes like this can usually be broken down into simpler right-angled triangles, making it possible to calculate distances that aren't immediately visible. Here are the steps. 5 squared minus 3 squared gives us 25 minus 9, leaving 16. The square root of 16 is 4 meters. With the true perpendicular height known, we can calculate the total surface area of the tent face. Half the 6-meter base multiplied by the 4-meter height equals 12 square meters. If we need a zipper to run along the base and up both slanted roof edges, we add the outside boundary lengths together. 6 plus 5 plus 5 gives us a total length of 16 meters. Without knowing the height, we couldn't have calculated the area or the length of the zipper. Pythagoras' theorem provided the missing data needed for both. To summarize, the area of a rectangle is length times width, while a triangle is half its base times its perpendicular height. For Pythagoras' theorem, identify the hypotenuse by looking opposite the 90-degree corner, then add the squares of the shorter sides to find its length. Subtract the squares if you are finding a shorter side, and always split isosceles triangles in half before starting your calculations. These rules allow you to determine hidden distances and physical dimensions in the world around you without always needing a measuring tape.